Hey everyone, happy Friday. In this video we are going to continue where we left off on Wednesday. So if you recall, on Wednesday we were working with this table here, and then we were doing a whole bunch of um, symbolic differentiation, right, using the information on this table. So the very last example, again using this table, is I think we left off on question 24, so it'll be question 25. Let me pull up my document here. Okay, question 25 says, what is the equation of the tangent line uh, 2f 2f at x is equal to 3. So remember that, right, the derivative is the slope of the tangent line at that point, right? And at that point they already gave us the x value of that point, right? X value of 3. So we're talking about the function f, right? So when x is equal to 3, right here, what is the y value of f at that point? Right? When you go to f of x, when x is 3, the y value is 3, right? So we're definitely talking at this point here then. And not only that, the table also gives us the slope, again, of the tangent line at that x value. F prime of 3 is 2 pi. So then the slope of the tangent line is 3, right? So that's the slope. And then all we're doing then is going to be plugging into that point slope form. We have our point, right, x1, y1, that's right here, 3 and 3, and then we have our slope 2, which is also, did I put 3 here? Oops, not 3, 2 pi. Okay, so we have our slope, our point, all you gotta do is just plug it in then. Y minus 3 is equal to 2 pi times x minus 3. So this is an acceptable answer. You can also add 3 to both sides. 2 pi times x minus 3 plus 3, right? And you just add this 3 to both sides. So this is also an acceptable answer here. You don't have to simplify. You're working with pi, right? So this would be okay. Okay, so that wrapped up the original document I had for you guys to review Unit 3. I'm also just looking over the Unit 3 key topics. And I also realized we didn't do specific inverse derivatives, and there's also implicit differentiation, which wasn't even, for some reason, the same document didn't have anything on that. So I have made the decision we're going to spend 3 weeks instead of 2 weeks reviewing Unit 3 and 4. So then next week on Wednesday, there's no school on Monday, right? Next week on Wednesday, we will spend time reviewing, that's when we'll cover implicit differentiation and inverse functions and their derivatives, okay? So the rest of this video, I think we should still spend more time covering chain rule examples. I think that's probably the best way to go about it. And yeah, we'll go from there, okay? So I don't know, we could title this more chain rule examples. I want to keep this video short too. I mean, I did say it was going to be no more than 25 minutes, so I do aim to meet that time, okay? Looking at the calendar too, I think we'll be fine in terms of pacing, considering what it is. So okay, so what we want to do here is now find the derivative using the chain rule. So again, I think for me it helps that whenever you're working with these type of radicals, maybe write it out as a rational exponent. We have the radical of that trinomial, so then it'll be parentheses to the 1/2. And then apply, right? It starts similar to what we were doing in Unit 2. multiply the exponent to the front there, subtract 1 from the exponent. 1/2 minus 1 will be a negative 1/2. And then, right, the chain rule says we'll take the derivative of the inside now. So then times the derivative of the inside. This is just a polynomial, so then you get 2x minus 4. Okay. And then what you want to do next is just clean it up a bit. So x squared minus 4x plus 5 to the negative 1/2, apply the negative exponent rule. That means you send it to the denominator. You already have a 2 in the denominator here. So this will be 1 over 2 times. And then I'm also going to convert it back into a radical. So then radical x squared minus 4x plus 5 and times 2x minus 4. And so then I think I'm seeing the 2, well, for the 2x minus 4, this guy right here, right, you can factor out a 2. So then this will be 2 times x minus 2 over 2 radical x squared minus 4x plus 5. 2's will cancel, and so then your final answer will be parentheses x minus 2 over radical x squared minus 4x plus 5. Okay, so there's the derivative. Number 2, got e to the 2x inside the cosine function. So let's see here. The derivative would be, right, the derivative of cosine, so g prime of x will be the derivative of cosine, which is negative sine of e to the 2x times the derivative of the inside. Now the derivative of the inside, right, would be, we know the derivative of e to the x is e to the x, so then you'll get e to the 2x, but the derivative of e to the f of x, right, chain rule would be e to the f of x times f prime of x, so then the derivative of the exponent, so then times 2, because the derivative of 2x is 2. And then so just clean it up, put it all together. Right, I'll move the 2 to the front. There is a negative there, so negative 2, then e to the 2x times sine e to the 2x. Okay. Next one, y is equal to ln parentheses 5x minus e to the x to the second. Now remember guys, I do encourage you to do those suggested problems. Right, it's the best way to get practice. Email me your work, ask me, are these correct? I will tell you if they are or are not, right, which ones to look at. It's the best way to make sure that you know how to do this, right? Looking at these examples like this, you might be like, oh yeah, this makes sense, right? But if you're now faced with it on a test, on an exam, like you will be, right, can you make sure that you'll still be able to do it? Best way is, again, practice, routine practice. Do the suggested problems. Okay, in number 3, I have an ln natural log function, right? So I'm going to apply a quick properties of logs. I have an exponent. That means I can move it to the front. Okay, so recall this from last year pre-cal, maybe even algebra 2. Okay, you can apply the rule of exponents for logs. And then now I can take the derivative here, right? The derivative of ln x, recall, is 1 over x prime, right? The derivative of x. So if I have this here, then y prime would be 2 times I'll have 1 over. Okay guys, like no joke, there was a power outage right in the middle of where I was at this step here, and yeah, you may not notice it in the video because I'm just gonna merge both videos, but yeah, for me it was a very awkward pause. So where I was right, you got 2 there, and then the derivative of ln x is 1 over x times x prime. So then the derivative of the inside of the function. What's the derivative of inside? Well, these are just 2 terms being subtracted, right? The derivative of 5x is 5. So there's my 5. Okay, and then the derivative of e to the x is just e to the x. So minus e to the x. Put all this together, right? A good answer. You don't have to multiply the 2 in. You can leave it like that. If you did, that's fine. All over 5x minus e to the x. Okay, there's your derivative. Number 4. Make this straighter. G theta is equal to sine 2 3 theta. And then I also had to grab a timestamp of the video. We were 10 minutes in, so that means that leaves us now with, well, we're about almost 2 minutes in, so about 13 minutes. So in this problem here, right, one way to rewrite this to help us see it would be, the correct notation, right, is sine squared 3 theta. You can also write it like this, sine 3 theta squared. Okay, because what this will help us is help us see that when we take the derivative, we'd multiply the 2 in the front, right, the exponent, times sine 3 theta. So you subtract 1 from the exponent, and then times the derivative of the inside. Sine theta, that derivative is cosine, so cosine 3 theta, right, times the derivative of the main of the trig function, 3 theta, so then the derivative there would be 3. Okay, now put all this together. You got 2 times 3, so then g prime theta is 6 sine 3 theta cosine 3 theta. Okay, and that would be your answer. Okay, cool. Next, number 5, got another trig function here, cotangent x squared plus 3. The derivative of cotangent is negative cosecant squared. Remember, these are, unfortunately, and I know there's a lot of rules. I was on your shoes too. You have to memorize all the rules. Okay, the derivative of cotangent is negative cosecant squared x squared plus 3, then times the derivative of the inside. So 2x, just 2x, right, because the derivative of 3 is 0. And so put this all together, you'll get negative 2x cosecant squared x squared plus 3. Okay. Let's see, 4 minutes plus 10, 14 minutes. That leaves me with 11 minutes. So let's go do some more. Let's go with this one. So this is number 6. Sine, well, g of x is sine of e to the x squared. So then g prime of x is the derivative of sine, which is cosine, okay, to cosine e to the x squared times the derivative of the domain there. The derivative of e to the x squared would be e to the x squared times the derivative of that exponent, which is x squared. Derivative of x squared is 2x. So then put all this together. You want to move those terms to the front there. 2x e to the x squared times cosine e to the x squared. Here's another one. Y is equal to ln 3 times e to the x minus 4x, all that to the second power. So first things first, I'm going to exercise the rule of exponents there for logs. So that means I can move that 2 to the front there. So I'm only dealing with ln 3 to the ex minus 4x. And then the derivative of ln, so y prime would be 1 over the argument times the derivative of the argument. Derivative of this would be, well, 3 is just a constant, right? So you can just, it's a constant, a coefficient, so it stays. Derivative of e to the x is e to the x minus the derivative of 4x is 4. And then you can put this all together, and again, you don't have to multiply this 2 in, you can just leave it outside. If you do, it's fine. That will be your answer. Let me see, let's go with this one. I think this would be a good one. Sine of square root of 2x. So, chain rule here would be the derivative of sine is cosine, right? And then square root of 2x times the derivative of the inside, right? The derivative of the inside there, let me just make a side note here. You can rewrite that as 2x to the 1/2, right? Square root of 2x is 2x to the 1/2. And so then if you take the derivative here, that'll be 1/2 2x, and then you subtract 1 from the exponent, right? The 2's would cancel. Actually, no, just kidding. Terrible. 2's will not cancel. Okay, but 2x to the negative 1/2, if you apply the negative exponent rule, you'd move all that to the denominator. So I'm actually getting 1 over 2 square root of 2x. Okay? So then times the derivative of the inside, right? I got 1 over 2 square root of 2x, and then though times the derivative of the inside, okay, the inside of the radical, okay, because the way to look at it, it's like you got cosine, right, of basically square root of f of x, right? So you have to take the derivative of, which we just did, of the radical, right, of f of x, and then times the derivative of the inside, f prime. In this case, 2x. The derivative of 2x is 2. Okay? So then the 2's will cancel there for sure. And so then I'm getting y prime would be cosine of square root of 2x all over square root of 2x. And this would be the answer. Cool. Cool. So do a few more here. Running short on time. Number 9 says y is equal to secant of x minus 3x squared. Now the derivative of secant x is secant x tangent x. So then y prime would be equal to, again, the derivative of secant x is secant x tangent x. So then no, that's not correct. The derivative of secant x, and this is me now having to refer to our rules here. Let me quickly Google this. Give me a quick moment. Yeah, it's derivative of secant x is tangent x secant x. So yeah, no, I was correct. Okay, cool. So then y prime would be, oops, Jesus, camera okay? Yes, it is. It would be secant of x minus 3x squared times tangent of x minus 3x squared. Okay? Again, the derivative of secant x is secant x tangent x, or tangent x secant x, same thing. Okay? And then times the derivative, of course, of the inside. Chain rule, so the derivative of x is 1 minus the derivative of 3x squared is 6x. And so, I mean, there's really nothing you can do aside from just moving this to the front. And so that'll be 1 minus 6x. I'll put a bracket, secant x minus 3x squared tangent x minus 3x squared. Boom. Okay. Looks like maybe we have time for a final one. So we'll wrap up chain rule examples with this one here. Number 10. Square root of x squared minus 7x minus 8. Again, for me, it helps to just write all this out in rational exponent form and then convert back later. So that'll be all that, the polynomial, the quadratic polynomial to the 1/2. So multiply the exponent to the front, so f prime of x would be 1/2. All of this, subtract 1 from the exponent, so negative 1/2, times the derivative of the inside. The derivative of the inside would be 2x minus 7. It's this to a negative exponent, right? So I'm going to move all that back to the denominator. So then this would be, if I move all this back to the denominator and then convert it back to a radical, that'll be 1 over 2 square root of x squared minus 7x minus 8. And then times 2x minus 7. And so then, I think really the only last step is, I can't factor out a 2 from 2x minus 7, so then my answer will be 2x minus 7 over 2 square root of x squared minus 7x minus 8. Okay? So that's it. That wraps it up. Okay, plenty of chain rule examples right from Monday's lesson and now from today's. Again, on next week Wednesday, there's no school Monday. Next week Wednesday, we'll spend more time looking at some more Unit 3 topics, particularly implicit differentiation and inverse function and their derivatives, and then we'll transition to Unit 4 from there, and we'll spend an additional week reviewing Unit 4, okay? It's a very important one. So, and it also buys more time for you guys to catch up on those notes if you haven't done so. Okay guys, see you next week.